On RT2-1, we're going to write linear equations. So, and I apologize, there's a typo on these notes. In standard form, a, b, and c are going to be integers, and you'll write your equation as ax plus by equals c. You're also probably familiar with slope-intercept form, which is y equals mx plus b, where I put slope in for m, and my y-intercept goes in for b. And then I have point-slope form, where m is my slope, and I have some point x1, y1. So we're going to look at a few different examples. And we're going to start with the green one first. And I'm looking at that green line and I'm saying, okay, with my slope, when I find another point on that line, I'm going up to 3, and I'm going over 1. Be careful here, each square is really a half, so 2 squares is 1 here. My y-intercept is at positive 2, so if I put it into the form y equals mx plus b, I get y equals 3x plus 2. I can follow the exact same strategy with that red line. This time my y-intercept is at -1. My slope, when I find another point, I'm going up 1, 2, and over 1. Plugging it into that form y equals mx plus b, I get y equals 2x minus 1. We'll do that blue line next. This time my intercept is at positive 4, and this time my slope is negative. So I'm going down 2, 3, and over 1. So down 3, over 1. Again, I'm still able to plug that in. I get negative 3x plus 4. And then when I look at that goldenrod line, I don't have my y-intercept. I can't just look at it. So instead I'm going to say, okay, I'm going to find a point, and I'm going to find another point. And I know, and I'm actually going to choose a different point. We'll choose this one. I'm going up to 3, over 2, and I don't know my y-intercept. I can't just look at it. So instead I'm going to use a point. So my x value is 2 at this point, and my y value is -2. And I'm actually going to put it into point-slope form. So I'm going to have y minus a -2 becomes a positive, equals my slope, times x minus 2. And then it depends. If I have to put it into this form, if the question says I have to, then I need to do some distributing and add my 2 over and combine some like terms. But if it doesn't say I have to put it into slope-intercept form, this is an equation. I can leave it just like that. So we're going to do some more example where we're writing equations of lines that go through a set of points. And I need 2 things. I need my slope, and then I need a point. Okay, I've got 2 points to pick from. I'm going to use my slope first. So my change in y, I'm going down 4. My change in x, I'm going down 2. -4 divided by -2 simplifies to be +2, so I'll use 2 for my slope. And then I'm going to take y minus y1 equals my slope times x minus x1, and all I need to do is plug in values for y1, x1, and my slope. We said our slope was 2. I can pick either point now. I'm going to pick this one because it's written first. So I'm putting 4 in here, x minus a -3. I need to switch this to a plus, and boom, I've got an equation. Now if it says it has to be in slope-intercept form, then I would need to go ahead and distribute my 2. And add the 4. So here I've got one equation in slope-intercept form, and I've got another in point-slope form. If it doesn't specify which one to write it as, I can choose either. We'll do another example going through some points here. Again, I'm starting by finding my slope. My change in y, I went down 7. My change in x, I went up 4. So I get negative 7/4 for my slope. I'm going to do y minus either point that I want. I'm going to choose this point. Minus a negative 3 will become a plus 3. That has to equal my slope, negative 7/4, times x minus 4. Again, if it says it needs to be in slope-intercept form, then I'm going to go ahead and distribute and clean things up. But if it's just asking for any equation, this works just fine as an equation. On this example, we're getting a little more complicated. So now we're given our slope, and we want it to go through the midpoint. So I need to find my midpoint, which remember is just the average of my x's. So I'm going to add them and divide by 2. Average of my y's. Negative 1 plus 5 is 4. Divided by 2 is 2. 16 divided by 2 is 8. I'm going to use this point and the slope that they give me and throw it into point slope form. So I'll have y minus 8 equals my slope 2 times x minus my x value 2. And again, if it says that it has to be in slope-intercept form, I need to distribute my 2 and add my 8 over. But if it doesn't say that, I can stop right here. Another one just like that. This time my slope is a half, and it's going through the midpoint of these 2 points. So I'm starting by finding my midpoint. I'm going to average my x's. Two plus 10 is 12. Divided by 2, I get 6. 16 minus 8 is 8. Divided by 2, I get 4. So I'm using this point as my midpoint. I'm going to do y minus my y value, 4, equals my slope times x minus 6. Again, if I need it in slope-intercept form, I'll go ahead and distribute and add my 4 over. If it doesn't say that, I can stop right here. On this one, we're asked for perpendicular bisectors. So we're going to take it one step further. I know a bisector will go through these 2 points, so I'm still finding my midpoint. I also, though, because I want it to be perpendicular, I'm going to find my slope and then take the reciprocal of that slope. So my midpoint will be 2 minus 6 divided by 2, 3 minus 5 divided by 2. 2 minus 6 is negative 4, divided by 2 is negative 2. 3 minus 5 is negative 2, divided by 2 is negative 1. Then I'm going to find the slope of that original line segment, so the one that we want our equation to be perpendicular to. My change in y is negative 8. My change in x is also negative 8. If I want a perpendicular slope, the negative reciprocal of 1 will be negative 1. So I'm using the negative reciprocal of the line segment slope, and I'm using the midpoint of that. And with those 2 pieces of information, I'm writing my equation. So again, I'll have y minus a negative 1, so it becomes a plus 1, equals negative x minus a negative 2 becomes a plus 2. We'll do another one just like that. We're again finding the perpendicular bisector. So I need to find two pieces of information first. I need the midpoint, because that's what it'll pass through. And I need the slope so that I can make sure the slope that I use is perpendicular. My midpoint will be 1 minus 5. I'm averaging my x values divided by 2. 5 minus 5 divided by 2. 1 minus 5 is negative 4 divided by 2 is negative 2. 5 minus 5 is 0 divided by 2 will still be 0. So I'm using this point when I write my equation. And now I'm going to find the original slope. In my original line segment, I went down 10. And I went down 6, which simplifies to be 10 over 6 or 5 over 3. I need the negative reciprocal for when I write my equation so that it's perpendicular. So I'm going to do negative 3 over 5. So I'm using this slope and this point to write an equation. I'll have y minus my y value 0 equals my slope times x minus my x value. Since it's a minus 2, I'll make that a positive 2 to add that on. We have a few more examples just using that perpendicular bisector idea. Same idea every single time. I'm finding the midpoint and I'm finding the original slope. My midpoint here will be 6 plus 3 divided by 2 and 0 plus 3 divided by 2, which simplifies to be 4.5 and 1.5. Then I'm finding my original slope. I'm going up 3 and then I'm going down 3, so that original slope is negative 1, which means my negative reciprocal of negative 1 is positive 1. I need to use my midpoint and my negative reciprocal slope to make sure that my equation is perpendicular. So I can do y minus 1.5 equals, since my slope is 1, I don't really need to write it. If you really wanted to, you could. Most mathematicians choose not to, though. Times x minus 4.5. Our final example, again, we're finding the perpendicular bisector. We're given our endpoints, so we need to find the midpoint so that it's a bisector, and we need to find our slope so that it's perpendicular. My midpoint will be negative 1 plus 5 divided by 2. And then I have 2 plus 3 divided by 2. Negative 1 plus 5 is 4. 4 divided by 2 is 2. 2 plus 3 is 5. 5 divided by 2 will be 2.5. My slope then, I'm going up 1. Negative 1 to 5, I'm going up 6, which means my perpendicular slope will be negative 6. I need to use this point and this slope to write an equation in point-slope form. So I'll do y minus 2.5 equals negative 6 times x minus 2.